This is part 2 of our discussion of normal curve and z-scores. So if you haven't seen part 1, go ahead and take a look at that and then move on to this one. In this episode, we are going to calculate z-scores, and I'm going to show you some different techniques. So the formula for z-scores is z equals the x minus the mean divided by standard deviation. So it's not too difficult. The most complicated part is calculating the standard deviation so that we can do this equation. So we're going to go ahead and do an example, and we're going to use these test scores here. Apologize, some of them are written in, but we're going to use these test scores. These are actual test scores from a semester when I used to have only 4 exams and they were worth 75 points apiece. And so these are real test scores from students in that semester. Okay, so we are going to go ahead and calculate the z-score for a score of 72 from our data that is posted on the previous slide or earlier in the video. So the first thing that we have to do is we're going to have to calculate standard deviation because standard deviation is a part of the equation for the z-score. So I'm going to go ahead and write out our equation for standard deviation. S equals the square root of the sum of x minus the mean squared divided by n minus 1. So that's our equation for standard deviation, and so we're going to start by using our table method. So we're going to have the first column be x, the second column is going to be the mean, the third column is going to be x minus the mean, and then our last column is going to be x minus the mean squared. So I'm going to go ahead and list my x's. I'm going to list them in order from smallest to highest, and there are going to be 20 of those. So this is going to be a little bit of a lengthy example. So we have 58, 61, 61, 63, 64, 67, 67, 68, 68, 69, 69, 70, 71, 72, 72, 72, 73, 74, 75, and 75. All right, so the first thing we need to do in order to calculate the standard deviation is we're going to have to calculate the mean, correct? So we're going to need the mean for this column. So the mean is the sum of x over n. So we're going to add all of these up, and it's going to give us 1297. And we're going to divide by n, which is 20. And so our mean is going to be 64.85. So we're going to go ahead and put that over here in the mean column, 64.85. And it's going to be the same all the way down. So then we're just going to take our mean, or our x, and we're going to subtract our mean. So 58 minus 64.85. And then we can square them. You can either do that now, or you can do all of these first and then square them all. It depends on what you want to do. If you've already got the x minus the mean in the calculator, you might find that it's easier to just go ahead and square it. We're just going to go row by row, or column by column. So then we have 61 minus 64.85, so negative 3.85, and that repeats. And then we have 63 minus 64.85, so negative 1.85, and then negative 0.85. And then we switch into the positives, and we're going to have 2.15, 2.15, and then 68 minus 64.85 is 3.15, and then 4.15, and then 5.15, 6.15, 72 minus 64.85, 7.15, and we have 3 of those, and then 8.15, 9.15, and then 10.15 twice. All right, so that's all of our x minus the means. So now we're going to square each of those. So remember, when you're squaring a negative, you're always going to end up with a positive, no matter what your calculator tells you. So it's going to be 46.92, 14.82, 14.82, 3.42, 0.72, 4.62, 9.92, 17.22, 26.52, 37.82. We skip up to 51.12, and we've got 3 of those. And then we have 66.42, 83.72, and 103.02 twice. Okay, so now in our equation for standard deviation, we want the sum of the x minus the mean squared. So we have x minus the mean squared for each one, so now we're going to sum those up. We're going to add that column together, and that's going to give us the sum of x minus the mean squared equals, and it's going to be 718.10 is what I calculated. So if I'm going to take that number and I'm going to put it back up into my equation for standard deviation, I'm going to have the square root of 718.10 divided by 20 minus 1, because 20 is how many x's we have. So 20 is our n, or our total. So we're going to have square root of 718.1 divided by 19. We're going to have square root of 37.79, and that's going to give us 6.15. So 6.15 is our standard deviation for this data. So that's step 1. So if you recall, the equation for the z-score is x minus the mean divided by standard deviation. So let's go ahead and calculate a z-score, assuming that we're looking for a z-score for a raw score of 72. So someone who scored a 72 on the test, we want to calculate what their z-score would be. I'm going to go ahead and go to a clean page. And here we're going to do a z of 72. So I write that way so we know that we're looking for a z-score for a raw score of 72. And that's going to equal 72, so x minus the mean, 64.85, divided by standard deviation, which we calculated as 6.15. So it's going to be 7.15 divided by 6.15 equals 1.16. So a z-score for a raw score of 72 is 1.16. And what that tells us is that the person who scored 72 is 1.16 standard deviations above the mean. So they are that far away from the average, above the average, which is good. That would be a good score to have. All right, so we are going to continue on. I'm going to tell you what all of this means. We're going to go ahead and stop there for part 2. We've just calculated the z-score for a raw score of 72. And in part 3, we are going to continue on and see how this relates back to that normal curve.